Welcome to the Journey Shake Chem. I'm so excited today because we're going to do lab. So please do the 2 warm-up questions to the best of your ability. We'll discuss them in a moment and then we'll go on to the lab. Number 1 asks how the boiling point and densities can determine the relative concentration of 2 solutions. Well, the boiling point rises with the more particles we have. We learned that about colligative properties. And therefore, the more particles we have, the higher the boiling point. As far as density of the solution is concerned, we know that when a solution is more dense, it must have more particles. And therefore, we can also determine the relative density of the concentration of the solutions. If we have more particles, it will be more dense. Number 2 asks, what is a saturated solution? Well, in this lab, saturated solutions are particularly important because some solids will go into solution more easily than others, and therefore a saturated solution will have more particles. Calcium hydroxide is not as soluble as sodium acetate. And we see this because calcium hydroxide only 0.185 grams of the calcium hydroxide will go into 100 milliliters of water. And sodium acetate, there are 119 grams that will go into 100 milliliters of water. That's how we determine what the saturation point is for these solids. And you can see that only a very small amount of calcium hydroxide will go into solution versus the sodium acetate, 119 grams, will go into the same volume of water. And therefore, a saturated solution of calcium hydroxide contains much less of the particles than the sodium acetate. And therefore, the density of this solution will be much greater. And we'll see that when we take the measurements. And we get to go into the lab. I'm so excited. However, I do want to also illustrate this point to you with a description of iced tea. When we have warm tea, we can get much, much more of the sugar into warm tea than we can iced tea. When we have cold tea, the extra drops out of solution, and a saturated solution will show that the solid drops to the bottom. And therefore, hot tea is much sweeter than cold tea. We can only get cold tea to a certain degree of sweetness. So you can keep trying, it just drops to the bottom. And therefore, warm tea can be much sweeter than cold tea. Well, now we get to go in the lab. I'm so excited, and I will see you in the lab. Well, here we are in the lab again, and you know how excited I get? I just get so excited. And we're doing lab particles, aka colligative properties. Well, the first thing I must do is find the density of my 2 solutions. And I'm going to mass an empty graduated cylinder. And the mass of my empty graduated cylinder, we need to make sure it's in the middle of the pan. Is 26.93 grams. 26.93 grams is the mass of my empty graduated cylinder. Now I'm going to add 10 milliliters of my sodium acetate solution. It is a saturated solution, so it has all the sodium acetate in it that it could possibly hold. And I'm going to pour 10 milliliters. And I want the bottom of the meniscus to be on the line of the 10. quite, but I have a little dropper here to help me to get it exactly. There we go, 10 milliliters. Mass of that. I will put it in the middle of the pan and get a mass of 37.79 grams. 37.79 grams. Now I am going to empty my sodium acetate into a waste beaker and rinse the graduated cylinder, and I'll be right back. I have rinsed out my graduated cylinder and am prepared to put in the calcium hydroxide. I'm going to stir it a little bit because calcium hydroxide, again, remember we discussed the solubility issue, and I want to make sure that I have as many particles in the solution as I can. I'm going to pour 10 milliliters in here, and I want the bottom of the meniscus to be on the line. And it's a bit difficult to see because it is so milky. Now I'm going to get its mass. I will put it in the center of the pan. And the mass is 36.81. 36.81. Is the mass of my calcium hydroxide. Well, isn't that interesting that the same volume has a smaller mass? That's very interesting. We'll have to look at what the density of that is, but I can kind of tell that it's going to be less than the density of the sodium acetate. Very, very interesting. Well, now I got 10 milliliters of each one. I get the mass of each one. I can determine the density. The next part we need to do is determine the boiling points of these saturated solutions. And I'll see you at the Bunsen burner. Well, here we are at my favorite place, getting ready to use that old Bunsen burner. Well, first I need to measure out 50 milliliters of distilled water. And actually, the volume that I'm going to use to boil is not critical, but I am going to still, for scientific method, use the same amount of each one. I will pour it into my graduated cylinder here to get 50 milliliters. And I want the bottom of the meniscus to be on the line. Now, this is also a source of error because the position at which I look at it, we sometimes have what is called parallax. Woo, I got too much there. And the parallax is when the eye level is not right on. And so when we look at numbers, and I'm sure you've noticed this in labs before, is that I think it's one volume and you think it's another volume. I'm sure that's happened. And I'm just going to go ahead and put this, well, no, I'll pour it out a little tiny bit and try to get it on the line there, the meniscus. It's a delicate operation. Don't want too much. And then you can see that I have 50 milliliters of my distilled water. And then I'm going to pour my distilled water into my beaker and get it ready to boil. Now, the boiling point also is difficult sometimes to identify. I'm going to wait until I get it boiling and bubbling, and I will try to be as consistent as possible when determining the boiling point. Well, here we go. I'm going to light that Bunsen burner, turn on the gas, and give it some spark. Woo! It just didn't want to light right away. So I'm going to turn it down a little bit. And I'm going to go ahead and heat this water to the boiling point. And I'll be right back. Now my distilled water is boiling, and I'm going to take it to the boiling point. The boiling point here is 96.0 degrees Celsius. 96.0 degrees Celsius. Now we have to do the boiling point of the sodium acetate. I'm going to turn off this liquid. And that was a little hint as to that I'm at a little bit of an elevated altitude. And I'm going to go ahead, and all thermometers are not necessarily extremely accurate, but the consistency is what's important because the error will cancel and we'll see the trend of what's happening. Well, I'm going to remove this thermometer and I'm going to rinse my solution. I'm going to take the distilled water out. And I will return, and the next time I see you, there will be sodium acetate on the ring stand. And I'll be right back. I removed the distilled water and replaced it with my sodium acetate. I measured out 50 milliliters of my sodium acetate, just like I measured out the 50 milliliters of the distilled water. I'm going to turn on the Bunsen burner so that I can get it to the boiling point. And I just love that Bunsen burner. Here we go. And I will go ahead and heat this up. And I'll see you as soon as it's again. And now I'm ready to measure the boiling point of the sodium acetate. And when I look, I see 101.0 degrees Celsius. 101.0 degrees Celsius is my boiling point for my sodium acetate. I'm going to go ahead and rinse out the beaker and measure out 50 milliliters of my calcium hydroxide, get it ready to go, and we'll be right back. I have measured out 50 milliliters of my calcium hydroxide. It's the one that's cloudy. Well, very interesting. Now I'm going to light the Bunsen burner one more time and get it to the boiling point. And here we go. Ooh, I love doing that. Okay, so here we go. I'm going to heat this up to the boiling point, and as soon as I get there, I'll be back to see you. Well, here we are at the boiling point of the calcium hydroxide, and it seems to be 98.0 degrees Celsius. 98.0 degrees Celsius is the boiling point for the calcium hydroxide. Well, that's very interesting to look at the data and see the trend. Well, you have all the data you need. Now you can write it up and answer the questions. I will give you a hint, though. On one of the further investigations, it asks for the molality. You must plug it into the equation of the change in the temperatures that are given on the front of the lab or on the first page of the lab, and you have every variable that you need to solve for the molality. Well, that was some fun, and thanks for being here, and I can't wait to see you tomorrow. Bye!